Alright, so for this lesson we're talking about nth roots. So here we're given the power of the root is 3, so it will be the cube root of negative 216. Now with even indexed roots, you would have an imaginary in this case, but with odd indexed roots, you would actually be able to find this root with a real value. What you'll now do is do the cube root of negative 216 by saying, alright, I know that negative 6 times negative 6 times negative 6 would be negative 216, or negative 6 cubed. And then the cube root of cube would cancel and you'd be left with negative 6. This can also be done on the calculator. In order to type that into the calculator, you could actually hit the math key and go down to the fourth option. The fifth option would actually allow you to do any indexed root, but the fourth option lets you do the cube root. And now you can type in negative 216 and hit enter to get negative 6. So there is the calculator option there. Alright, on part B, you're doing the fourth root of 81. Now, something that we know is 3 to the fourth power would be 81, which the 4's would cancel and you would have 3. Now, watch out here, you can only take the root of positive numbers whenever the index is even. It was only okay over here because the index was odd. To type that into calculator, you would actually hit the math key, go down to the fifth option which says X root, and you will type in the fourth root. So 4 is my index. I'll hit to the right and then type in an 81 as my radicand and get 3. Instead of using roots all the time, we can represent roots with rational exponents. It does show a to the 1/nth will be the nth root of a, so that would look like the nth root of a, and a would be to the first power because of the numerator. So what's going on here is whatever the denominator is of your exponent is the index of the root. The numerator is the power of your base. So if you had, and what this is showing, and I'll just rewrite it out to the side, if you had a to the m over n, that would equal the nth root of a to the m power. Now there's the technicality that you should apply the root first and then raise it by the power. That sometimes rarely does make a difference, but we're not going to see a situation where that would actually cause any issues today. There is also the negative exponent would move this to the denominator and it would still come out the same way. Now if we're looking at these expressions, we'll see how we could use that information to help us here. 16 being raised to the 3 halves. What I would do is rewrite 16 as 2 to the 4th power. There are a few different ways to do this, but usually I write it as the most prime base that I can. And then the 4 would multiply the 3 halves, because when you raise a power by another power, you multiply. So 2 to the 4 times 3 halves. 4 times 3 halves ends up being 6. So 2 to the 6th power. And then 2 times itself 6 times over would be 64. That's doing it by hand. We are going to be expected to use a calculator really on these. On this one over here, first thing I would do is write it as 1 over 32 to the 3/5 power because the exponent was negative. Next thing I'm going to do is actually rewrite 32 as its lowest base, which would actually be 2 to the 5th power is 32. So 1 over 2 to the 5th power is replacing my 32, and it's being raised to the 3/5 power. Now what I can do is multiply the 5 and the 3/5, so 1 over 2 to the 5 times 3/5. The 5's are actually going to cancel here pretty nicely, so it's 1 over 2 to the 3rd power. You're sorry that ran off the screen there. There's what I was writing. Now, 5 times 3/5 was 3. 2 times 2 times 2 would be 8, so my final answer here is 1 over 8. So something you could have done on these is actually typed them into the calculator. I'll show the second one because it's a little trickier. So 32, hit the power key to the negative 3/5 and hit enter. And you're going to get 0.125, which is the decimal version of 1/8. If ever you're needing to convert that, hit the math key and hit enter on convert to fraction in order to see that it is 1/8 in fact. So now I'm going to show this using the TI-84. You could also be using Desmos perhaps, but if I'm using the calculator as it says to, and we're going to round our answer to the nearest 2 decimal places, which would be the nearest hundredth, I'll go ahead and type this in as 9 to the power of 1 divided by 5 and hit enter. So that's going to come out as 1.55 for A. And this is just very straightforward stuff where we're just making sure that you're calculator competent here. And then 12 to the 3/8, 3 divided by 8. And that's going to be 2.54 if you're rounding correctly. And then on the last one, go and type in the parentheses. Now this is again where you want to go to the menu that's under the math key and go to the 5th option down, which will give you any indexed root you want. So you're going to want to type in the 4th root of 7, hit to the right, then close your parentheses, and then do to the power of 3. And it's going to be 4.30. Since I am rounding to the hundredth, I would actually show that 0 that it is. All right, that's it for the third example. All right, on this example 4, what you're going to see is an equation. Now, I did make a note here. I made a big emphasis on quadratics that you're supposed to do the plus or minus square root. Well, that's because it was a square root and the index was even. Now, with the thing that you have to consider is you'll only do that plus or minus is when the index is even. If the index is odd, you're not going to do plus or minus. So on this first problem, you do just divide both sides by 4, and 128 divided by 4 is 32. So x to the 5th power is equal to 32. Now, the reason why you don't have to do plus or minus is because since it's positive, I would have to be raising a positive number to the 5th power to get 32. There's no way I could raise a negative number by the 5th power to have gotten this value. So that's the reason for not using plus or minus. So what I'm going to do is on my next step, I'm going to show that x is equal to the 5th root of 32. And now I'm ready to type that in. Since you're allowed to round to the nearest hundredth, the calculator is the perfect tool to use in this situation. So math, 5th option for any power root, which is the 5th root of 32, which I know to be 2. Because 2 times 2 times 2 times 2 times 2 is 32. Now, I do want to point out that there are other solutions possible here. We are only finding the real solutions. So in Math 3, you take this to another level where you might be finding imaginary solutions to pair with this. All right, now, we don't have to worry about that here in Math 2, though. On this next problem, the first thing I would do is actually take the root on both sides. So x minus 3 will equal the 4th root of 21. But on this one, since the index is even, I do have to consider that it could have been positive or negative when I raised it to the 4th power to get positive 21. All right, at this time, I will calculate that value, or I might actually just go ahead and kick the 3 over by adding it. So I'm going to get 3 plus or minus the 4th root of 21. Since I'm expected to round, I couldn't simplify this. This would actually be as simplified as it gets for my 2 answers. But since I'm expected to round, I am expected to go to my calculator and type each of those in. So 3 plus the 4th root of 21. And I'm going to hit enter, and I'm going to get 5.14. And I was rounding to the nearest hundredth, so I rounded correctly. X is approximately 5.14 is one of my 2 answers. One of my 2 real answers, I should point out. And I'm going to hit second entry to bring up that previous entry I just had and go over here and hit a minus instead of a plus to represent that other answer. 0.86 if I round to the nearest hundredth correctly. That 5 would round up. 0.86 is my other real answer. Just to point out, there would be another 2 answers here, and I'm betting that they are imaginary since we didn't find them here. But again, that's a Math 3 topic, not a Math 2 topic. We're only interested in using roots a little bit to find our real answers. These were irrational, but since we were allowed to round, that was actually kind of nice to use the calculator. This problem might look like an absolute nightmare. You should pause the screen and read through it. But what's going on here is they are giving you a formula for the rate, which is R. So all I got to do is just plug in everything else here that they're telling me what it is and type it in the calculator. So a very straightforward problem. So the rate that the hospital is considering here is equal to 1 minus, and now I'm going to start substituting things in. S is the salvage value. So you're going to look back through this problem and be like, what was the salvage value? That's the value it went down to. So that's 8,000. Divided by C is the original cost. This machine cost them $50,000 at the beginning. And if you would have rather done that 8 divided by 50, totally fine. You could have even reduced it more, but it's all right if you leave it as such. 1 divided by N, and N is the useful life of the item in years. The hospital expects the useful life of this machine to be 10 years, so 1 over 10. And now that I've dropped in every single value that I can, it's really just a can you use your calculator kind of problem. So I'm going to type this in as it reads 1 minus parentheses 8,000 divided by 50,000. Close off the parentheses, hit the exponent key, and type in 1 divided by 10 for my exponent. All right, now I'm going to hit enter. So the rate, it doesn't say what to round to here. Usually with percentages, we do to the nearest tenth of a percent, which would be the thousandth place. So I'd be considering this as 0.167. And that's an approximate, so I'm putting approximately 0.167. The reason why that'd be to the tenth of a percent, so I could actually represent this rate as a percent by multiplying it by 100. I could even do that in the calculator, times by 100. If you don't feel comfortable moving the decimal right 2 places, that's all you're doing. 16.7%. Either of those answers would be accepted. If it was multiple choice, they'd only have one or the other. All right, that's a wrap on the video. Thanks for watching.